Hi everyone, it's me. I wanted to do some quick review on factoring so that you guys could use this to help you with any of your Khan Academy quizzes or any of the other stuff that you're working on. So what I did here is I just want to review some basic kinds of factoring, and then I'm going to also talk about factoring where the leading coefficient is not 1. So the whole idea is basically factoring is another form of dividing. It's basically unmultiplying stuff. So in the past, we've used the distributive property to multiply things. And what I want to do is show you how we undo that. Now we do that because when we get into quadratics, we're going to be graphing quadratics. And one of the best ways to graph them is to use intercepts. And we come up with intercepts by using the factors. Okay? So when you're trying to find a greatest common factor, it's the same as what you used when you were in elementary and middle school. You find a number, the largest number that you can, that divides into both terms or numbers, okay? Now, here we have two numbers, and as you can see, they're both divisible by 3. So what I'm going to do is divide both terms by that greatest common factor, okay? It's going to take you some time to figure out which one's the greatest common factor sometimes, but be patient with yourself. You're going to get much better at your times tables. If you thought you were rusty before, wait till you finish up. You're going to be really good at it. So I'm going to divide everything here by 3. Now, when I factor, unlike dividing, when I factor, I want to keep that thing that I've divided by outside. So what I'm doing is dividing 21x by 3, and I get 7x, right? And then I have 15y divided by 3, and that's equal to 5y. And I can always double check this by redistributing and making sure I end up with what I started with. Okay, so here I have a variable in common in addition to a number. So these are both, first things first, I want you to look at the numbers. They're both even numbers. They're both divisible by 2. Our greatest common factor is going to be 2. Okay, here, these both have the variable c in them. So what I'm doing is I'm dividing by the variable c with the exponent, the lowest exponent I see. Now remember, this has an exponent of 1, even though we don't write it. So I'm going to divide both these by c. And I'm using my exponent rules like I've always used. So when I'm dividing, I subtract my exponent. So 14 divided by 2 is 7. And then c squared divided by c is just c. And then on the outside, I put my 2c. And then anything divided by itself is 1. Okay? This one, as you can see, I can't divide any number into 5 and 12. 5 is prime, and 5 does not go into 12, and they don't even have a variable in common. So when I can't factor them out at all, I just write prime, meaning the only factor is itself and 1. Okay? Now let's look at this one. This one's a little bit more complicated. I like it because it's getting us to think. So both 8 and 22 are divisible by 2, and that is their greatest common factor. But let's look at the x's and the y's. There is an x here and an x here, and my lowest exponent is 3. So I'm going to divide both terms by x cubed. And then there's a y here and a y here, and the lowest exponent for y is 4. So this is called taking out your greatest common factor. So 8 divided by 2 is 4, and then these just go ahead and cancel out. So it's 4 times 1, which we don't even put in there. So on the outside, I'm going to put 2x to the third, y to the fourth. All right. Now, I'm going to divide 22 by 2, and I get 11. Subtracting the exponents, 5 minus 3 is 2x squared. Y to the 6 minus 4 is 2. So it's y squared. All right. So let's go ahead and let's take it another step. Let's do these last two. So this is all greatest common factor. As you can see, the coefficients here are 10, 9, and even though we don't see it, it's 1, right? So there's no numbers in common with those, but if I look at my A's, each one of those has an A in them. Now the smallest exponent, if I look right here, is 1. So I'm going to divide everything by A. And then I'm also going to look at the B's, and the lowest exponent is 1. So I'm dividing everything by AB. So I have AB on the outside, and I get 10 AB, A to the 2 minus 1 is 1, B to the 2 minus 1 is 1, plus 9. My A's go away, B to the 2 minus 1 is just B to the 1, minus 1A. Okay, and there we go. All right, so that's enough of the greatest common factor. I wanted to give you guys some practice for that. But what about difference of squares? Difference of squares, if you noticed, when we had a product of a sum and a difference, so let's just say we have x plus 4 times x minus 4. This is called a product of a sum and a difference because both these binomials are exactly the same, but the only thing that changes is this one has a plus, which makes it a sum, and this one has a minus, which makes it a difference. So I'm going to go ahead, and if I wanted to FOIL them out, I do x times x, which is x squared, and then x times negative 4 is negative 4x, 4 times x, which is 4x, and 4 times negative 4 is negative 16. As you can see, these go ahead and cancel out, and so this turns into x squared minus 16. Okay, and that's what's called a product of a sum and a difference. So what we do is we remember that when we have any number where they're exactly the same, but one of them has a plus and a minus, it ends up being an a squared minus b squared. Okay, and this is called a difference of two squares because both of these are perfect squares and there's a minus in between them. So this is one of the easiest things to learn, but some of the hardest things to remember because but one of the big things is that if you have two terms that are both perfect squares and there's a minus in between, that's easily factored out to a product of a sum and a difference. Okay, so a way to find them is to make sure you pay attention to both of these. If there's two terms, there's a hint for you. If there's a minus in between them, there's another hint for you. Now let's check to see if these are perfect squares. Well, the square root of a squared is equal to a, and the square root of 64 is equal to 8. Okay, so those are two perfect squares. So to factor this out, this would be a plus 8 and a minus 8. And I could do a minus 8 times a plus 8. Order does not matter. Okay? Let's look at this one. The square root of y squared is just y. And the square root of 289 is 17. Okay? So I do y minus 17 times y plus 17. Okay? Now, here's another one. This one's tricky because this is a perfect square and this is a perfect square. But look right here. This is a sum. So this is a sum of two squares is always going to be prime. Okay? So I cannot factor that. So let's look at these next two. Here I have a 1 minus 25n squared. Well, the square root of 1 is always 1. And the square root of 25n squared is the square root of 25 is So I would do this as 1 minus 5n times 1 plus 5n. Now you cannot switch the order here and do 5n minus 1. Otherwise, you've got something different. So be very careful with that. Now let's just do these last two right here. The square root of 16x squared is 4x, and the square root of 49y squared is 7y. Okay, so I'm going to do 4x plus 7y times 4x minus 7y, and then we're done. Now, any exponent that has an even, any even power that has an even exponent, a power that has an even exponent, the square root of that is just half of that. So if I do square root of w to the 4th, it's just w squared. And the square root of 100 is equal to 10. So this is going to be w plus 10 times w minus 10. All right? So again, big thing is these are not hard to learn. They are just hard to remember. And I really want you guys to pay attention to that. Okay? So the next type of factoring that I'm going to talk to you guys about is just your general trinomial factoring. And that is when you have a trinomial and you're trying to figure out what two factors end up being that. So what I do is I look at these two numbers. I look at this number and I look at this number right here. And I say, okay, my last number is 6 and my middle number is 7. So what two numbers multiply to 6 and add to 7? Okay? And it's going to matter when you're looking at your signs here. Okay? So take a look at those. So that's going to be 6 and 1. All right? So this is going to be x plus 6 times x plus 1. So one of the things that I would suggest you do anytime you're doing one of these is do what I call an X puzzle. And here I've got negative 38 and negative 17. Please be very careful to include your signs. That's so important. Okay? So, and then here I've got negative 36 and a positive 9. So remember this. When you're multiplying two binomials, you do the first, outer, inner, last. And this last product is this number right here. So remember, if you have two positives, a positive here and a positive here, you're going to have two sums. If this is negative, one of these is going to be negative, right? And if this is positive, but the middle is negative, like right here, one of these are going to be two negatives. Okay, so hopefully you can start to see that a little bit. So I'm going to make X puzzles here. And okay, so I have the product of negative 38 and I have negative 17. Okay, so if I did negative 19 times positive 2, that gives me negative 38. So this ends up being m minus 19 times m plus 2. All right. And then here I have what two numbers multiply to a positive 16 but add to a negative 10. So if it's a positive, they're both going to be two negatives, right? And that's negative 8 and negative 2. So this is going to be y minus 8 times y minus 2. Let's look at negative 36 and 9. Okay, we have a positive 9 and a negative. So one of these is going to be positive and one of them is going to be negative. So what if I did 12 and negative 3? 12 times negative 3 is negative 36. 12 plus negative 3 is a positive 9. So this ends up being p plus 12 times p minus 3. Okay, so hopefully this gives you guys some idea of what you need to do as far as doing these. I wouldn't worry too much about ones like these. Let's try to go ahead and just do these next two right here. So if I have a product of negative 45 and a sum of negative 12, let's see what I have here. How about negative 15 and a positive 3? Okay. It takes me a while to figure this out. Remember, I've been doing this a lot longer than you have. So remember, C minus 15 and C plus 3. Okay. And then what about 64 and negative 16? So that's a negative 8 and a negative 8. So that would be W minus 8 times W minus 8. All right. And there you go. All right. So I'm going to go over next time on factoring a trinomial with a leading coefficient other than 1. And I'm also going to do one. Let's see if I have some grouping. I'm also going to do some grouping practice as well because they're very much related. And we'll go back from there.